So in this video we will see insertion in splay trees. See, in the previous video we have discussed what is splay tree, advantages and drawbacks of splay trees, some applications of splay trees, and how splay trees are different from other balancing binary search trees. So you can check out that video in this I button, right? And in that video also we have discussed that how to perform searching operation in splay trees. What is splaying operation, right? In this video we will see the insertion operation in splay trees, right? After that, after this example, we will see, we will write down the code, or you can say we will write down the algorithm for insertion operation as well as for splaying operation. Means first of all we will discuss it with the help of an example. We will create a splay tree by inserting these numbers, and then we will write down the algorithm for insertion operation as well as splaying operation, right? Now see, as we have discussed in the previous video, all the basic operations that we can perform in BST like search, insert, delete, those operations will be performed in splay tree and the procedure would be same as in BST. The difference is what? Those operations are going to be followed by one basic operation of splay tree, that is splaying operation, right? Now in this case also, first of all we will insert the data and then we will do splaying. Splaying means the data we have inserted, on that data, on that element we are going to perform splaying operation. Means now we are going to make that inserted node, the newly inserted node, as the root of the tree, right? And why we are going to make that element the root of the tree, that we have discussed in the previous video, because it's because the advantage of the splaying tree is what? Because of this step only the most frequently accessed elements move closer to the root, so that we can easily or quickly we can access those elements, right? Now first data you want to insert is 15, right? So obviously this is a BST self balancing BST, or you can say it is a self adjusted BST. It is roughly balanced, not strictly balanced like AVL tree. So first of all you will create a node, and after that you will insert that thing. In node we have what? The data, that is the value 15 plus the left pointer plus the right pointer. I am not here representing the node, right? I'll just write down 15, the data of that node only, right? Now initially there is nothing in the tree, so what you will do? We will insert 15 and we will create a node and we will simply insert the 15 in the tree. And now you do splaying on this data, on the data on which you are going to perform the operation, that is insertion operation. So 15 is the data we want to insert and 15 is the root. In splaying we will make this as a root, but this is already root, so no need to do anything, right? Now next is what? 10. Now simple BST insertion first of all you will do, compare with this one. 10 is less than 15, so where you will insert? Here, to the left of this 15, right? Now this is not done. In splay tree now you do what? Splaying on this data, the data you have inserted, that is 10. Means now we will make this 10 as the root of the tree. How we are going to make this as a root of the tree? What is that splaying operation? Check if the newly created node, or this is what? The data on which you want to do splay operation is what? Having parent only, and the parent of this is what? Root. Means this is not having any grandparent. So this is what? A zig situation, right? Now check out, this is left child or right child? So this is left child of this root, so we will do what? Right rotation, or you can say zig rotation, right? These rotations we have already discussed. Right rotation about this parent of this node you have inserted. So right rotation means you will pull this 15 downward and 10 would go upward. So now this is the tree after insertion of this 10, splay tree, right? Next is 17. Insert 17 in this tree. Same, that BST insertion, greater than 10, greater than 15. So here you will insert 17. But now you will do splaying operation on this 17. We will splay the 17. Now check. 17 is having parent as well as grandparent. Now this is what? And 17 is to the right of its parent and 15 is also to the right of its parent. Means on the same side, both this node and parent are on the same side, right? Either may be left or right, but here these are on right side. So this is what a situation of zig situation, right? Now here first of all you will do what? 2 left rotation you need to do to make this 17 as a root. So first rotation would be about this grandparent, next rotation would be about this parent. See, don't get confused that first rotation would be about this parent and then this. No, in this situation first rotation would be about this grandparent of the newly inserted node. So now left rotation means we will pull this downward and 15 would go upward, right? After first left rotation, again left rotation around this 15, now 17 would go upward, 15, and here we have 10. Now this is the tree after insertion of 17. Now see, this you can say a zigzag situation or a zigzag rotation, sorry, right? Somewhere it is written that the left rotation we have already discussed is a zig rotation, the right is zig rotation, right? But somewhere both the cases are taken into one situation, that is zigzag situation. So it is what? Zigzag, or you can say left rotation situation. Fine, it's up to you how you will write, either zigzag situation or zigzag left rotation, both are correct, right? Now this is the tree. Now here you will insert 7. How you will insert 7? Compare with the 17, less than 17, less than 15, less than 10. So now here we will insert 7. Now splay the tree, splay this 7, right? Because you need to make the 7 as a root of the tree. Now check, 7 is having parent as well as grandparent, and 7 is left child of parent, and this parent of 7 is also left child of its parent, right? Both are on the same side, so it is a zigzag situation. Here first of all 2 right rotation you need to do. If these are left child means right rotation, here these are right child, so means a left rotation. So 2 right rotation you need to do. Now first right rotation would be about this one 15, grandparent of the 7. So now the tree would be 17. We will pull this 15 downward and 10 would go upward. So after first right rotation, tree something like this. Now again right rotation around about this 10. So we will right rotate this, means 10 would go downward and 7 would go upward. So now here we have 7, 10, this side and this side 15. But we are not done yet because 7 is still not root. Now check which case you need to apply. Now 7 is having, the parent of 7 is root node, means this is not having any grandparent now. So this is what a zig situation. Now check, it is left child or right child of the root. It is left child of the root, so do right rotation. Right rotation about this parent. So right rotation means we will pull this 7 downward and 17 downward and 7 would go upward. So now here we have 17. Now see, after pulling this 7 downward, now 7 is here. Now the right child of 7 is 10. The right child of 7 is, where this 10 would go? The right child is now 17, so it would go to the left of 10, and 15 would be as it is at the right child of this 10. Now this is the final tree after insertion of 7. So this is what you can say a zig situation or zig rotation. Now we will insert 13. Compare with this one, simple BST insertion. First of all you need to perform greater than 7, less than 17, greater than 10, less than 15. So here you can insert 13. Now splaying on this element, splay this 13. Now see, 13 is having parent as well as grandparent, but this is a zigzag situation. Why so? Because this and this both are in opposite direction. One is in left direction, one is in right direction. This is not this case that both are in same direction. So it is what a zigzag situation. Now you need to check out which rotation you need to apply, left or right first of all. See, this is the node, this is parent, or you can say this is grandparent, G you can say, right? Now 13 is to the left of 15. First of all, if this is the case that zigzag situation is there, then first we will perform the rotation on the parent only, not the grandparent. Here we perform rotation on grandparent, then parent, right? Don't get confused in this scenario, right? Now first of all we'll perform rotation on the parent. Now this is what, left child of parent, so we will do first of all right rotation on this parent. Now the tree would be something like this, right, after first right rotation. Now we will do left rotation, right, because it is a zigzag situation. Left rotation on grandparent on G. So now the tree would be something like this. Left rotation means we will pull this 10 downwards, so 13 would go upwards. So now here we got 13, here we have 10, and here we have 15. But we are not done yet, because 13 is still not root node, because we have to make this 13 as root node, because we are going to perform insertion on 13, right? So now 13 would be root node. So now what you will do, see, now 13 is having parent as well as grandparent. Now it is also a zigzag situation, right? So now, because both are in opposite direction, one is left, one is right, so 13 is to the left of parent. So first of all right rotation on parent, right, zig rotation. So now the tree would be something like this. We will rotate it something like this. So 13 would go upward, 17 would go downward, and here we have 10. Now see, 15 is to the right of 13, so it would go right of 13 and left of 15. But we are not done yet. Now zig rotation means now 13 is to the right of 7. Now zig rotation means left rotation on grandparent. So now the tree would be something like this. See here, the left child of 13 is 10 to the left of, but to the, it will go to the right of this 7, right? So now this is the tree after insertion of 13. Now insert 16. In this tree, where you can insert 16, see, greater than 13, less than 17, and greater than 16. Now here you can insert 16, right? Now see which rotation you need to do. Here we have the 16 is having parent as well as grandparent. Now it is right child of this one, and this is left child of this one. So both are in opposite direction, so this is also zigzag situation. Or here you can say this is zig situation. Both are correct, right? Now see, 16 is to the right of this 15, so we will do first of all left rotation on parent, right? So now the tree would be something like this. Left rotation on parent, so 16 would go upward, and here we got 15. Now we do right rotation on 17 on the grandparent. So now the tree would be something like this. But we are not done yet, because 16 is still not the root node. We have to make it root node. Now check, 16 is having only parent, not grandparent, because 16's parent is root node. Now this is the situation of only zig rotation, right? Now here you need to check which left or right rotation. So 16 is right of 13, so you need to do left rotation, or you can say here zig left rotation, or you can say a zig rotation. So now after this rotation, the tree would be, see here, the 16 is, left child of 16 is 15, means left child of 16, it would go to the left of 16, but here we have 13, so it would go to the right of now this 13, that is. So now this is the final tree. I guess we are left with 10. See here, to the right of 7 we have 10. So here you will write 10, to the right of 7 we have 10, and here also to the right of 7 we have 10. So this is the final tree now after inserting of this data. So now I hope you got how to do insertion in Splay trees. Now we will write down the algorithm for insertion operation, right? And then we will write down algorithm for splaying operation. Fine. So now we are going to perform insert operation on the tree T, and n is what? N is the number or the node I want to insert. See here, n is not the data, that is 15. Here n is what? The complete node, in which data part is 15. Here we have left pointer, here we have right pointer. But I am not writing this thing, simply n means this node. You need to take care of this thing, right? Here, suppose now I want to insert after the 16, I want to insert 14. So same, the BST insertion process, and we are going to follow. First of all, we will compare with this root. If this is less than root, then we will go towards this one, the left side, and like this. If greater than, then we will go towards the right subtree, right? So this thing you will write down here. This is same as the BST insertion. So suppose I am taking a temp variable, and there I am storing the root address, right? T dot root, something like this you can write. And I am taking another variable y, and there I am storing null. Why you are taking this y? This thing you will get cleared further. Now see, Now we will write down a while loop while temp not equal to null. If you write down the algorithm, then simply you can write down this thing, right? Temp not equal to null. See, till then we are going to move either left or right. It depends on the value of this, the value you want to insert, right? So first of all you will set y is equal to temp. So now you will write if the data you want to insert, that is n of data. See, n I have told you this is a node and the data part is having 14. Here we have left pointer, right pointer. Now this is having null, this is also null. So n of data is less than temp of data. Right now, see, here we have temp because temp is equal to t of root. Root is this one. So temp is a variable which is containing address of this root. Temp is not containing 16. Temp is a pointer variable. See, here I have already told you, if I am taking n, this is a node. Temp is what? I am taking a complete, you can say, pointer variable, pointer to node. Y is also containing address of these nodes, right? If the 14 is, see, temp of data is 16, 14 is less than, so we will go to the left, right? So now temp becomes temp of left. Whatever the value in temp of left, that address would be stored in temp, right? So now you can say temp is pointing to here, right? And now see, else you will do what? Temp is equal to temp right, else we will go to the right side. Fine. Once you reach where you want to insert the data, suppose here I want to insert 14, so once you reach here, so now you will write down what? Here after this while loop you will write this n dot parent is equal to y. Now see, why we are writing this thing. Initially temp is this one, right? So now while temp not equal to null, temp is not null because it is containing address of root node, y is equal to temp. Now see, y is equal to temp. Now temp was this one, so y is also now this one. Y is also containing address of the root node, right? Now compare, n of data is 14, 14 is less than temp of data, yes. Now temp is equal to temp left, so temp becomes this one, right? Now again, while temp not null, yes, temp is not null, temp is containing address of this node, temp is not null. Now again y is equal to temp. Now y becomes here, now y is this one, right? Now temp is equal to temp left. So now see, check n of data. Now n of data is what? 14, less than temp of data. Temp is this one, temp of data is 13, but this is not true. So we will go to the else part, that is temp is equal to temp right. Now temp is this one, temp right means this one. Now temp is containing address of this node, that is 15. Now again check, temp is not null, yes. Now y is equal to temp. Now y becomes temp, that is y is this one. So now check, if n of data is 14, 14 is less than temp of data. Now temp is this one, temp of data is 15. Yes, the condition is true, so temp is equal to temp left. Now temp is equal to temp left. So here this node is having temp left is equal to null because this is not having any left or right child. So now temp is pointing to null. So now you can say temp is here, temp is null, right? Because this is not having any left child or any right child. So now temp is null. Now again check the condition, temp is not null, but this condition is now not true because temp is null. So we are going to exit from this while loop, and after this while loop we have this situation, right? So now you have got the location where you can insert the 14. It means 14 would be child of this 15, this is for sure, either left or right child. And so that is why I am tracking this y. So n of parent, n is 14, parent of this 14 would be y. See, y is right now containing address of this node, that is 15 node, and that is for sure because 15 would be parent of this 14, right? So now y is what? Parent of this 14. If still y is equal to null, means the parent of n is null. So n is not having any parent. Here you can say root would be that element which is having no parent, So no need to do any splaying. We will simply return and we will not do any splaying operation, right? So here you will check if still y is equal to null. After checking this, then we will set t of root would be n, right? Only one element we have, that is this one, that is this case 15 case. Initially the tree was empty, so we will insert 15, so 15 would be root, right? No splaying would be done if y is not null. Now else if, where to insert this 14, to the left or to the right, where you need to check. Now we will check else if this n of data is less than y is this one, y of data. So this n would be the left child of this y. So here you will set in the left pointer of y, we will store the address of the newly created node, that is n, right? Else y of right is equal to n. Now insertion is done, and now you will call what? Splay on this tree. On which element? On the data you have inserted, on the node you have inserted, that is n. See here the n is what? This address is suppose 100, so n is what? The address. So in the y of left means y is also address, y of left is this one. Suppose this is y is data part of y is 15, here the left. So in the left part we will store 100, right? So here we are considering it as a address, not the value. Value, if you want to access, then you need to access something like this, n of data, right? So here also you can write this arrow or arrow, something like this. Fine. Now we will see the algorithm for this splay operation. I am going to rub this one, and now we will insert. See here we have inserted this 14 after this algorithm to the left child of this 15. Now we will do splaying on this 14, because 14 you need to make this 14 as a root of the tree now. So now this is the tree after insertion of this 14. Now we will do splay on this 14, right? So we will do the algorithm for the splaying of this tree on the n node is what? 14, right? Now we will check all the cases of splay. Suppose this 14 would be the root. Initially, if suppose we have inserted 14, only one element, then 14 would be the root, so no need to do anything. We will do splaying till this 14 becomes root. So we will write down a loop while n of parent is not null, because if the parent of this node is null, it means that would be the root node, because root is not having any parent, right? Or here you can check while, you can write while n is not root node. Till then we are going to do some splaying. Now what you will do? Now we will check if the parent of this n is root node. In that case, either you will do zig or zeg rotation, means only one left or only one right rotation. That case may be there, right? So now here you will write what? If n of parent is equal to t of root, means both are same, right? The parent of n is root. Suppose taking this example, the parent of 13 is root, so here we will do what? Only one right rotation. Or if this is the case, then we will do only left rotation, left or right rotation on this one parent, or you can say on root of the tree, right? So now here also we will check now. If n is equal to n of parent, and n of parent means this one, so we will check whether n is left child or right child. According to that only we will decide we will do left rotation or right rotation. So now if this is the left child, suppose it is left, then we will do one right rotation. So here you will write right rotation on the tree, on which? On the root, or you can say on the parent of this n. So here you can write, you can pass parent of n. Else obviously we will do left rotation. Now this is one case. Second, you see this is one case, this is second case. Now third case is having 4 sub cases, that is if the n is having parent as well as grandparent. Now what you will write here? See, so now this part is within this if. Now we have else for this if, right? Else we have parent as well as grandparent. So suppose I am taking P is equal to N of parent and G is equal to P of parent. So P is parent of N, G is grandparent of N, right? So here you can say N is this one, parent is this one, and grandparent is this one. So G would be this one, right? Now we will check the 4 cases. If now here both N and P are left child, means suppose here I am taking 7 is N, so P parent for 7 is this one, grandparent is this one, so both are left child. It means we will do 2 right rotation, first right rotation on 16, then right rotation on 13, right? So here you will do, or simply here you can write, if you will not write this condition in algo, you can write in your simple English language, if both N and P are left child. Or this is the same condition C, N of parent, N is this one, N of parent is this one, parent of left means this one only, so N would be the left, P of parent and left would be P. So here you will do 2 right rotation. First right rotation would be on G and second right rotation would be on P. This thing you need to take care. First of all on grandparent, then parent. Now else if both N and P are right child, that could also be a case. So now here you can write, in this case we will do 2 left rotations. First left rotation would be on grandparent and then on parent. Now third case may be, now suppose I am taking this case. Now N is what? Left child of P, but P is what? Right child of G. So here what you will do? It is a zigzag situation. These 2 are zigzag situation. Fine. This is simply zig situation, right? Now here first of all we will do right rotation on parent, because this N is what? Left child of this one. So right rotation on parent, right? And after that we will do left rotation on grandparent. So see, now after the rotation the tree would be something like this. Now again left rotation, you can say zag rotation on this grandparent. So now the tree would be 13 would go downward, 14 would go upward, right? But still we are not done, because obviously I am taking this in while loop. So N of parent, now N is this one, N of parent is not null. So again we are going to follow steps, whichever if condition is true, that condition we are going to follow. Now here what you will write, else if N is the left child and parent is what? The right child. Then first we will do here right rotation on parent. Then we will do left rotation on grandparent on G, right? Else fourth case is only left case is what? This N is what? The right child and parent is what? Left child. So in that case no need to write down that condition. Simply first of all we will do left rotation on parent, then right rotation on grandparent, opposite to this case. So this is the algo for splay. Now here see, this is not yet done. Now again the while loop, we are writing these in while loop. So while N of parent is not null, N of parent is not null. So again check, if N of parent is equal to T of root, yes, N of parent is now root, yes. So now we will enter into this if condition, not in else condition. Now we will check if this is left or right child. It is left child, right? So we will do right rotation on N of parent. N of parent is this one, and here we will do right rotation, right? Means this is a zig situation. So after right rotation the tree would be, final tree would be, here to the right of 14 we have 15, so it will go to the right of 14 and to the left of 16. So here we have 15. So this is now the final tree after insertion of this case. Now see, here also the right rotation and this left rotation are also functions. So you need to write down coding for this right rotation as well as for left rotation. So let us write down the steps for the left and right rotations as well. Now see, let us take example of this right rotation of T, and N of parent would be passed. So in this case, suppose I am taking this scenario, N of parent is 16. So the address of 16 would be passed, and here I am receiving that address in X. right? That is a pointer variable. It is not simple variable, a pointer variable. You need to take care of this thing. Fine. Now this is x, right? Now what you will do, now I am taking this also because this is what n, right? This 14 I want to make the root node, so we have to store address of this also. So now this is what x of left, right? X of left is address of this 14, so you can store that thing in another variable, that is y. Y is equal to x of left. So y is a pointer variable which is containing now address of 14. Now this is y. Now how to do right rotation? Now see, steps are, after right rotation, see you can check the 14 right child is 15. Now 15 become left child of 16, means this 15 become left child of x, right? Now I am writing this step. So how you can write down this thing? See, x is this one, right? So x of left should contain y of right. Yes, you can see here x of left containing y of right, that is 15. Now next what you need to do, now see we have broken this link, right? So now here x of left means x of left is now containing this one, address of y of right. Sorry, we have broken this link, not this. Now we have to set this link, right? Means how we will set this link? Now the right of 14, see the right of 14 would be containing address of x. So here x we will store in y of right and we will return, we can return y, right? Address of this y node. See, these are y and x, these are pointer variables. Don't get confused. I am taking these as a variable, so I am not saying that this is a correct, I am writing a correct program. You need to take care of this thing, right? Now, how to do left rotation? How to write down steps of left rotation? See, here you need to take care. First of all, you need to set this link. If you write down this line first rather than this one, then see y of right is equal to x, means y of right is equal to x. So this is the link and you have broken this link, right? So now from where you can get this link of 15? So first of all set this link, after that set this link. You need to take care of this thing also. Now what about left rotation? Suppose here I want to do left rotation on this 14, right? I want to splay 16, right? 16 is right child, so I want to do left rotation. So after left rotation the tree would be something like this. See, the left child of the 16, left child of 16, and it would become the right child of now the 14. So I guess you can easily write down this in coding. First of all set this link, after that you can set this link, the left child of the 16. So now same here, x is this one, we are going to pass this 14 address because we are going to do left rotation on this thing. Now we will set first of all y. Suppose y is 16, that is why I am taking left rotation. I want to splay 16. So now we will set y is equal to x of right, right? Now we will set the link for this y of this left child. So now y of left now become, the 15 become now right child of 14, that is right child of x. So x of right, and now simply you can set what? Y of left would be x and you can return y. See, these are pointer variables. These are going to return address of these nodes, not value of the nodes, right? So this is all about insertion in splay trees. In the next video we will discuss how to do deletion in splay trees. So I'll see you in the next video. Till then, bye bye, take care.